In this video, we are going to address similarity and right triangle standard number 2, which basically is, I know what similarity is and I can use it. We know that similarity means same shape, different sizes. And so to investigate that standard of same shape, different sizes, we have 3 objectives. We will write a similarity statement, basically just seeing how do you write it down in the mathematical notation. And then we want to determine whether or not 2 figures are similar, or precisely figure out which one is similar. If we're given a bunch of shapes, find the pair that are similar to each other. And the third one is we can set up a proportion from similarity and figure out a side length. Thus, the first type that we will examine are here. These are similar triangles. Now, please note a number of observations about these similar triangles. I've said several times that similar means same shape, different size. How do you ensure that they are the same shape? Well, let's start by taking a look at the angles.
It's just the smaller one is double.
Yes, it is. That's the short observation is the smaller one is doubled to make the larger one. Yes, if you want to skip ahead in the video, that's the point I'm making, but I'm trying to provide all the details exactly beyond that. Yes, all the matching angles, your corresponding angles are the same, so 26 is corresponding with 26. And we've already discussed having congruent corresponding angles when we were doing congruency. Likewise, we'd have 36 congruent to 36, 118 congruent to 118. And my board glitched out on me for a bit there. Let me try to erase that as much as I can. But the point is, if you have similarity, or in order to have similarity, every pair of corresponding angles must be the same. If there's even one angle off by a millionth of a degree, they're not similar. Every pair of corresponding angles has to be perfectly congruent. As you also noted, there is also the scale factor. When we were considering the dilations in the plane for standard 1, we were consistently seeing the scale factor. To go from one of them to the other, you had to multiply side lengths by 2. You had to multiply the gaps by 2, or 4, or whatever the scale factor was. That scale factor is also in play here. When we examine the corresponding pairs, side length RT compared to side length XZ is 3 over 1.5, which divides out to be a scale factor of 2. In order to have similarity, every single pair of corresponding sides has to have that same scale factor of 2. So when we examine the left-hand side, we'd have SR compared with YX, 4 over 2, is likewise 2. Now please pay attention to how I've been setting these pieces up. With the way I've set it up, RT was on the left triangle, or the big one. XZ was on the right one, or the small one. The names we're using, left, right, big, small, aren't really important. However, it is important that when we conduct or calculate these pieces, that we do keep the same order. For my third one, let's say that I instead went and said YZ over ST, which is incorrect. It doesn't always have to be the bigger number, and I'll come back and address your comment there in a second, Tana. But if I set it up this way, I've got 3 over 6, which is 1/2, and what winds up happening then is we see that we have different scale factors, which makes it look like they're not similar. It doesn't matter if you put the big one on top, the small one on bottom. It does matter that when you calculate the scale factor, you're consistent with it. Every single time, it's got to be left, left, left on top. In general, there isn't a hard and fast rule for how you have to do it, but my preference is to put the pre-image on the top and the image on the bottom. In general, this is my preference. In this way, you would look at it and say, where was the beginning shape? The beginning shape gets moved to the ending shape. That's my preference. I know some people who always like to simply say, put the big one on top. Because if the bigger one is on top, then you're guaranteed to have a number that's larger than 1 for your scale factor. Well, I don't mind having scale factors of 1/2 or 3/4 or something like that. It's just a matter of preference. Ultimately, though, as you noted, when we take all 3 of them, then we'd have ST over YZ, 6 over 3, which is also 2. All of these wind up having the same scale factor. So they are similar. The definition of similarity actually requires that you check every single pair of corresponding sides for this similarity, for this scale factor. It also requires that you check every single pair of corresponding angles for congruence, which is a huge amount of work. 3 pairs of sides to check, 3 pairs of angles, and that's just for triangles. Quadrilaterals would have 4 pairs of sides, 4 pairs of angles, and so you'd have 8 things to check. Pentagons would have 10 things. It's a lot of work to verify similarity using a definition, which is one of the reasons why we like to use dilations in the plane. It's also the reason why standard number 3, how do you do shortcuts on triangles? So that way you don't have to do 6 things, you only have to do 3. Or maybe even 2. It depends on what those things are. Now, we still haven't addressed our first objective. The first objective for today was to write a similarity statement. This skill is virtually identical to writing up a congruency statement. It's about putting the matching pieces together. For instance, I'm just going to say triangle on the left, STR. And the order you put them down isn't important, just as long as, it goes point to point to point. We don't want to say congruent. And so we will not use the congruency symbol because they're not congruent. Congruent means same shape and same size. These are not same size, so it's inappropriate to use this symbol. The symbol we use for similarity is this. Basically, it's the little squiggly on the top of the congruency symbol. And so making certain that we put down their corresponding parts. S corresponds with Y, T corresponds with Z, R corresponds with X. And this is one correct way to write up a similarity statement for this triangle. It's not the only correct one that we could have done. If we wanted to, we could have said triangle XYZ is similar to triangle R. And this tells us the exact same information. Likewise, if we have something like this written, we could create proportions based on these. XY, position 1, 2. Remember when we were doing congruence, we said position 1, 2 is congruent or equal in length to position 1, 2. Well, that will not be the case anymore because, of course, they don't have to be the same size. However, we will still use the relationship of position 1, 2 matching position 1, 2. Instead, where's my eraser? Come on. Instead, what we get is position over position equals your scale factor. 1, 2 matching 1, 2. And continuing 2, 3 matching 2, 3, we could write up YZ over ST will equal your scale factor. And using the wraparound, position 1, 3 matching position, I did it again. Position 1, 3. So XZ matching RT will equal the scale factor. We will still use the corresponding parts. We just use them in a slightly different way now. All of this information was geared towards understanding the similarity statement, being able to write it, being able to understand it. Our second objective. One of these three on the bottom is similar to the one on the top. Which one?
Well, we're told one of them is similar.
Thus, we need to determine which one. How can you do that? What would you need for them to be similar? Okay, we need all the angles to be congruent. We don't have angles to look at. We were told one of them is similar. So basically, if we can figure out and rule out two of them by process of elimination, we'd know the third one would have to be because we're told one of them is. Well, we can't check the angles because there's no information there, but we can check the scale factors. We know they have to have the same scale factor. Okay, so what is the scale factor on the original? There are several different ways that we can check this. One way that people will use is to say 12 and 4 have a relationship between them. Well, if we take 12 divided by 4, it's 3. This is like what we were doing in the last video where we said the behavior has to match. Well, the behavior of the original, the bottom is 3 times as long as the right-hand side. In order to have similarity, that behavior has to stay. So where do we have another one that maintains the same behavior of the bottom being 3 times the size of the right? And you correctly identify it's this one. 9 is 3 times the size of the right-hand side of 3, so we've got it, we're done. Just thinking of mentally thinking of what we need is one way that we can do this. Well, how do you write down that thought then? One way to write down that thought is to actually set up and show this proportion. 12 over 4 is actually equal to the same thing of 9 over 3.
You probably recall from your
Algebra
pre-algebra
classes that you can verify this by multiplying each of the diagonals. 12 times 3 is 36. 9 times 4 is also 36. And because this is true, it checks out,
and we know that it was correct. This is one way to set up the proportion.
it's not the only way. Another way we could have verified this information was to actually take the corresponding pieces. 12 corresponds with 9, so we could take 12 matching, and then we'd have 4 and 3 for positions, and so we could put them down and verify with our cross multiplication. 12 times 3 is 36. 9 times 4 is 36. And so it checks out. That is correct. And we can see that trying this process on either of the other two shows that it doesn't work. If we tried 12 corresponding with 14, and we tried 4 corresponding with 6, setting up this proportion in the same way, we could multiply 12 times 6 is 72. 14 times 4. And since that's not true, we get that they are not similar.
Let's use that same set of skills here.
Which one is similar? So which one do you think?
Well, first of all, which way are you looking at it?
Are you trying to match the behavior of turning 6 into 15? Or, okay, we're trying the cross multiplication method, so which one is your intuition right now? Okay, looking at 8 and 20, so we're going to set up 6 corresponds to 8. And then 15 corresponds with 20. And people were, I heard them talking, saying, oh, what do you multiply, what do you end up getting? Okay, so what's 6 times, okay, 120. 8 times 15. Well, there's not a problem with doing scratch work. 8 times 5 is 40. And 8 plus 4 gives you 12. So it checks out. It actually is equal to 120. This one is similar. Piece to be careful about. What if the directions instead said which triangles
And there'll be 2.
are? It does not guarantee. You should be aware that just because the directions say which triangles are, it does not guarantee that there are 2 answers. It doesn't even guarantee that there is 1 answer. It could be none, it could be 1, it could be 2, it could be 3. Thus, you would need to go through. When the directions say, I forgot the L in triangles. If the directions say which triangles or which shapes are, you would need to check or verify whether or not it's similar for each of them. Fortunately, for this problem, we were told there's only one, so we don't need to continue. Okay? Which one is similar here? Okay. First thought was the first one.
No, it's the first one.
Okay, you said it's not the first one then. How do you know it's not the first one?
It's from cross multiply.
All right, you said cross multiply, so if you're cross multiplying, what are you setting up? Because there are a lot of different proportions we could create.
4 times 2 is 8. Or 6 and stuff.
Okay, so if I see what you're doing, you were taking the 4 and the 2, and matching that with 6 and 4. So 12 is not equal to 16. Okay, so it's not the first one. Jerica said try the second. So we would say 4 is matching 6, left matching left, and 6 over 9, bottom matching bottom. And since they're both 36.
Okay. Okay. Jerica set up her answer a different way, and I want to point out the technique she used. She didn't set up her proportion this way. Instead of focusing on the scale factor, she focused on the behavior.
In particular, she had hers set up, and I want to switch the color to, I don't know, purple, I guess. She focused 6 and 4 and noted 6 over 4. So bottom compared to left would have to match the behavior bottom compared to left. 9 over 6. And it still winds up being the same thing. 36, 36, they are the same. Or you could have also divided them both out. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. There are many different correct ways to do these. And so one of the challenges sometimes students find is because there are so many different correct ways to write it up, they sometimes get confused by the sheer amount of possibilities. Especially if we know as a teacher, I have my preference, and so in general, I tend to write it up the way that I like to do it. But that doesn't mean that it's the only correct way. We've seen 3 different correct ways to do this one, and surprisingly enough, there are probably, I have to go through and actually figure it out, but there are probably 10 more correct ways that we can do this. There are lots of correct answers when you're working with similarity, but there are lots of wrong answers too. Okay, so moving on to the third objective. Figure out a side length. In order to determine a side length, we will actually need to set up and use a proportion. It's based on the same idea of setting up your matching parts. In this instance, we would say you can turn 6 into 18 using a scale factor of 3. So one correct way to do this is to identify the scale factor and use it. To turn 6 into 18, we have to multiply by 3. So do the same thing. Using the same scale factor, 4 times 3 gives us 12 meters. Labels are important. And so we get the length xy is 12 meters. Yeah, that's done. This is not the only correct way to set it up. I admit this is my favorite method because there's virtually no writing. However, we could set up a proportion. 6 matches 18. 4 matches the unknown and use a variable. And now we can cross multiply and solve. 6 times x, 18 times 4 will equal 72. 72 divided by 6, x equals 12. And so we get the same answer. It's purely a matter of preference as to how you want to do them. My preference is the one in the yellow because, well, I'm lazy and it's less work, and I like it that way.
The blue, though, for many students who like working with proportions, the blue is a guaranteed length. They know how long it's going to be. They get to use the same strategy over and over and over. It works, so they like it. Well, pick your strategy. Figure out the length of AC. How would you prefer to do it? Do you want to set up a proportion, or do you wish to determine the scale factor? And the students aren't answering in class, so I'm going to pick mine with the scale factor. I would start by determining the longest side is going to have to match, of course, the longest side. Hypotenuse has to match hypotenuse. I know those are corresponding. Thus, I could look at it and say 7 gets turned into 35 using a scale factor of 7. Did I say 7 gets turned into 35? 5 is turned into 35 using a scale factor of 7. And so our challenge now is to determine, is it the 4 or is it the 3 over here?
So it's going to be 21.
You have several different ways that we could do that.
Well, one of them, identifying that
4 times 7 gives you 28.
we have that
28. 3 times 7
then gives you 21.
And so just logically thinking through what's going on is one particular way that we can do it.
If you didn't notice these parts, another way that you could have done it, AC is position 1, 3.
It has to match
Position 1, 3, which is ED.
And so you could use the similarity statement itself to identify the corresponding pairs that have to go together.
And on this one, I would like, on one of these, we should do the proportion method. So let's use that proportion method in question number 2, just so that we can further reinforce it for people who prefer proportions. Well, how are we going to set it up? 20 corresponds with 4, which means x will correspond with 7. We can cross multiply 4 times x, 20 times 7, and then divide by 4. 140
Divided by 4.
will equal 35. And so we're done.
On the problem on the left, for the problem on the left,
X is 35. And our last example to finish off our work for today. BC corresponds with FG.
well, do you want to set up a proportion or do you want to determine the scale factor?
Okay. Fawn immediately told me it's multiply by 3. So maintaining that scale factor, 15 multiplied by 3. 15 times 3 is 45. And so we have our solution. Thus, we've finished up with our focus today. We saw how to write and understand a similarity statement. We saw how to figure out if shapes are similar using a scale factor behavior or using
a proportion, and then we took those two strategies of
proportions or using scale factor to find a missing side length
when you have similar figures already.